Morning. Welcome. This is Professor C. Ravikumar Reddy from CBIT. Yeah, today we'll solve an interesting question. Yeah, it's also going to be a model question. Here is the question. A 6.5-meter ladder AB of weight W leans against a wall as shown in the figure. Okay. Assuming that the coefficient of static friction mu s is the same at both the wall and the floor contact. Okay. Yeah. You need to determine the smallest value of mu s at which the equilibrium is maintained. Okay. So your job is to find what is mu s value. Okay. The least mu s value. Okay. So if you try to solve this in a regular fashion, it is going to be a long answer question and it needs some 2 to 3 pages of solution. Yeah, so here is I present to you a short way of solving this. You see here, this is the angle made by the ladder with the floor. Okay, so I take tan theta of it. Okay, so it is 1 minus mu s square divided by 2 times mu s. This is the relation between the coefficient of friction between the ladder and wall and floor and the angle made by the ladder with the floor. Okay, keep this in mind. Yeah, now let us verify these answers, which one is going to be the correct answer. First, let me solve the left hand side LHS value, which is tan theta. So opposite side, which is 6 meters here, 2.5 meters here. It's a given dimension, 6.5 meters. So opposite side by adjacent 2.5. This works out to 2.4. Okay. Yeah. So whichever value matches with the right hand side, okay, if you substitute in the right hand side value, then whichever matches to this left hand side is going to be your answer. Okay. So just verify one by one. So option A. So I'll keep 1 minus 0.5 square by 2 times 0.5. So this comes to 0.75. So this is not your option. Next, go for option B, 1 minus zero point 0.4 square by 2 times zero point 0.4. So this comes to 1.05. So this is also not your option. Then option C, 1 minus zero point 0.3 square by 2 times zero point 0.3. The value comes out to 1.52. So this is also not matching with the left hand side. Okay. Now option D, 1 minus zero point 0.2 square by 2 times zero point 0.2. So this works out to 2.4. So this is going to be your option, correct option. Okay. So the friction coefficient need to be minimum zero point 0.2 to keep this ladder stable or equilibrium is maintained. Okay. Yeah, so this is the short way of solving this ladder friction problem just with this single relation in any model of this for any dimensions given. Okay, not just for this dimension, because here you see the weight of the ladder has no role to play. Okay, the equation whatever is given here, like tan theta is 1 minus mu square by 2 mu s, is nowhere related to the weight of the ladder. So it all depends on the geometry. Okay, so keep this in mind and use this equation wherever it is necessary. Yeah, thank you. We'll be back with the next question.